problem using any strategy. Okay, what does that mean, Ellen?
I thought to say that when the line crosses the x-axis.
When it crosses the x-axis? So when we have two separate equations, are you ready? When we have two separate equations, what you're going to do, and like, let's say it's really difficult to solve because this would be difficult to solve. You're going to take this junk, that junk, and then you're going to type that into Desmos. And then in a separate line, you're going to type this junk. Where they cross over, whatever the x value is, that would be your solution. Okay. Yeah. Okay, so wherever they cross over, whatever the x value is, that's going to be it. So I'm going to show you the example of this. No. It's two separate lines, and where they cross over each other, that is what our answer is going to be. So when we go into Desmos, no, not x-axis, x value where they cross over. Yeah. Okay, so when I type this in, I get something that looks like this. Okay, now Ellen brought up a point. Are you listening? Okay, Ellen said they cross over twice. So which one is the correct answer? They both are. X would equal -6 and X would also equal 2.269. Ta-da! About it. Okay. If you had, for instance, these two tables and they said, what is the solution? What you're going to look for is a repeat in the table. So what I mean by that is if we look right here, we have -6, 4. We have the same point in this table. That would be a solution, that -6. Okay, what was our other point? 2.269. Okay, we could probably, this one's a little harder to see because if we look at 2.269, that falls right here, right? Well, 6.2 is somewhere in between 4 and 13. That's why we kind of want to use that graph, right? But you could see that this would be an answer for sure. Cool. Nothing crazy. Okay. So if you had this question, if you are asked, where are the solutions to f of x equals g of x? That's going to be where they intersect on a graph. So on your paper, I want you to write this question down, and I want you to put where they intersect. And you're going to put x value. You don't care about the y value. Make a quilt. A quilter is buying fabric, 2 colors, light and dark. Consider the graphs that represent 2 constraints. What does the word constraint mean? Is what? To tighten or to restrict something. Okay, so explain why 2 satisfies the cost constraint but not the length constraint. So the cost constraint is right here, and the 0.22 is right here. Right here is where 2 would be. You see how it's in the shaded region for the cost constraint, but it's not in the shaded region for the length constraint. Okay, solutions are only going to work when they're in the shaded region. For both? No. Now, it says find at least one pair that satisfies both constraints. I want you to look at these 2 graphs, and I want you to figure out a point that would work for both instances. 6, 4, and 6, 4. Would that work? Yes. Okay. What else would work? The line between 8 and 12. 8, 2 would work. Let's try it. Yep, 8, 2 would work. Cool. So it's where it has to satisfy both conditions. Okay. 2, 7. It wouldn't on this one. That's okay though. All right. So go ahead, take a moment. I want you to write this down, but I want you to write a synopsis of it. Do not write it word for word. Take a moment, summarize it, put it on. Okay. So we have light and dark colors. he needs at least 9.5 yards of fabric in total. So the first thing what we want to do is we want to say X is going to be light and Y is going to be dark. Okay. And we're going to say X plus Y, because that would be in total, right? And it has to be at least 9.5.
So it can be
Greater than 9.5. Okay. Now we got to write a cost constraint. We have $9 per light color. So that's going to be 9X. And then $13 for the dark color, which is going to be 13Y. And we can spend up to 110. We can't go past $110. Are there any other constraints that we need to think of? Can you have negative yards of fabric? No. So we're going to have X is greater than 0 and Y is greater than 0. Yes, Elizabeth. I could have 9.5 yards or more.
Oh, okay.
Yeah, at least would be the bare minimum. Yeah. At most is the other way. Yeah. Okay, when we get back, what you're gonna do after you write all these inequalities is you're gonna go into Desmos and you're gonna type them in. Type them in. Okay, the inequalities. Yeah. All right. I'm like spinning all over the place. I apologize. Okay. Ready? Okay. When you type this junk in, you're going to get this magical piece of doom. Okay. All right. So once you get here, then what's going to happen is, oh my God, delete. Okay. You see how like there's like 4 color. Oi, I'm trying to show you colors. Okay. You see how like all 4 of those colors are like meshed over each other? Okay. You can turn off this X and Y and you can see it a little bit better. When you combine red and blue, what do you make, guys? Great. Okay. So when you look at this, you're going to only have answers in this little tiny sliver right here. Okay. Take a moment. Draw that equation, or I'm sorry, draw this picture down on your paper. Y'all. One more example like this, because y'all are pretty good about writing these inequalities, but we just went on a little bit of practice. Reading this, it says advertising packages. An advertising agency offers 2 packages for small businesses who need advertising services. A basic package includes only design services. Premium includes design and promotion. Agency's goal is to sell at least 60 packages in total. The basic advertising package has a value of $1,000 and the premium has $2,500. Goal is to sell more than $60,000 worth of small business advertising packages. I don't know what that means. Oh. Okay. Thanks, guys. Okay, so first things first. I also don't like really long passages. Like that's a lot of information to take in. So when you're reading this through, I would highlight the important things. Like, first of all, there's 2 different packages. We got basic and premium, right? We need to sell at least 60 in total. So we can go ahead and write an inequality from that, right? We can say X represents the basic, Y represents the premium. And then we can say X plus Y has got to be at least 60 packages. Okay, then we're going to read the second paragraph. So basic package, going to be $1,000. Premium package, $2,500. And we got to sell more than $60,000. So again, we can write an equation or an inequality. So 1,000 times X plus 2,500 times Y, and we're trying to do more than 60,000. There's a lot of zeros that you can't see. Ta-da! What do you mean? Why do I do it like that?
You heard.
Oh. Different types of functions that we got to know. Ready? We got square root. Probably want to draw this little table out.
What?
Yeah. Probably should have mentioned that. We've got absolute value. value. Okay, we've got cubic, we've got quadratic, we got cubic roots, we've got linear. Okay, so go ahead and take a moment, write this out. I'm just kind of filling it in so that you get design. Awesome. Okay, take a moment, write these down because these are the rough sketch of this guy. Okay, we've got square root that's going to look like whoop, that. We got a straight line for linear. Absolute value, remember it's a v. Here's your cubic root, quadratic, and then cubic function looks like this. Whoop. Yep, it's the sound effects for me. Like this. This says classify each function in the system, then graph the system of inequalities, shade the solution area. So first of all, what type of function is this guy right here? Fantastic. What about the next one? That one's a little tricky. It's a straight line. So what is that going to be? Fantastic. Okay. When you type this junk in, remember, in order to get this little absolute value bar, you're going to hit shift and then the little black slash button. Is that a backslash? Is that a front slash? I'm not sure. Slash button. Okay. And then we're going to type that into Desmos. And we're going to look at this shaded region. Okay. Okay, Jared. All right. So we're going to type that in. Bum, 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 bum. Yeah. Come on. No. Okay, so when we look at this, where does it have both colors overlap? Right in, yeah, okay, so like all this junk. Okay, one thing, wow. Okay, one thing I do want to include is that this line right here would be part of the solution, but anything that lies on this dotted region, not included in the solution. Okay, solid line, good. Dash line, not any answer. No, you, well, yeah, you can. So how you change it to a solid line is you put an equals. But since our inequality didn't have that, yeah, it is not customizable. You cannot have it your own way. This is not Burger King. Okay, so that finishes that one up. Yay. No, not forever. Stay tuned. Listen, I'm trying to give you like the shortened version of everything. No, don't want to do this. This next lesson is over key features. Yeah, so like if I gave you this table, could you tell me key features such as the x-intercepts, the y-intercepts, the increasing or decreasing, max or min, end behavior maybe? Now, since this is a linear function, that's going to look like y equals mx plus b, right? Okay, so what would be my y-intercept? Okay. So it would be -2 for that b. What would be my slope? It's going up by 1. Okay. Is it going up by 1? It's going up by 1 and 2. So 1 over. Okay, let's try this again. So we're looking at this. Our y-intercept is -2. Now, if we were trying to find the slope, you could use this formula, right? Yeah, that's throwback to 6th grade. So if I took 2 points and I plug them in, that would give me 1/2. My slope's going to be 1/2 x minus 2. Are there any x-intercepts we can tell? Try again.
4.
Yes, it's going to be 4. Could you tell me the end behavior? Right. And then as x goes to negative infinity, y is going to negative infinity. Exactly. Is it increasing or decreasing? Increasing. Is there a max or a min? No. You don't have to write this one down. Again, same concept, identifying key features. So max, min, x-intercepts, y-intercepts, that kind of thing. Okay. Feel like that. Okay. And point. Oh, I don't know. Last one. Last one. Finals.
That's one forever. They say you will Tuesday.
Mm.
And you see that period on. 3, 8 points. And then we have the next one.
All right, so if we draw the line of symmetry, we could get this. You know what, Ellen? You try to draw a straight line on this thing. This one's symmetrical. There we go. That is. Oh. I can't get that to go straight at all. Is it it's like a combination? Like, you know how like people are like, I can't be a surgeon because XYZ. No, like I could be the blood in the guts wouldn't bother me. It would be like the caffeine addiction that I have. I can't, and my hands are just they're jittery. Look at this. So close. One more time. All right, pause. One more time. No. I think there's a line tool on here. Pause. We can find that out. Where is it? Go back. There's a check mark.
On the jaw.
Draw
There,
a straight line. Look at that. I ate that up. Thank you. I'm like real excited about these stamps now though. Like, look at that. So exciting. Okay. All right. I need a nap. Okay. So determine what type of symmetry the functions have. This is always the dumbest thing we do in math. I don't know why we do this. It's fine. We have odd, even, or neither symmetry. Yeah. Yeah. So determine what type of symmetry the functions have, if any, by looking at the graph. So on your paper, I want you to write even, odd, or neither, and leave a little bit of room because I'm going to give you depth. So an odd function. Okay, see, now I messed up my drawing. Okay, so odd, even, or neither. Okay, so with an odd function, let me try that again. Even function is going to be symmetric about the y-axis. Okay, so that means that you could draw like a straight up line up and down and it folds on top of itself, then it would be evenly symmetrical. So stupid. All right, odd is going to be symmetric about the origin. And what's crazy is most functions are neither even or odd. Yeah. Another way to look at this is to say, if you took your function and you plugged in negative x, then it should be equal. Yeah. I'm going to show you an example of that in just a second. For an odd function, you're going to be able to flip it over the x-axis. Like it's a reflection over that. So neither one of these situations actually worked out. Well, okay. So let me give you an example of this. Example. Okay, if I have 5x to the 5th minus 4x to the 3rd plus 2x. And we're trying to see if this is an odd function. What we're gonna do is we're going to plug in negative x into the equation and see if we get this at the end. So we're gonna plug in negative x into this equation. So watch this. This is magic. Negative x goes in. Okay, and we're trying to determine if it's the same or if it's different. If oh, JK. Thanks, Almi. Okay, so what I'm gonna do is think about it. If I take -1 and I raise it to the 5th power, that's still gonna give me a negative out front, right? It's gonna be -1. So this would be -5x to the 5th. If I took -x and cubed it, that's still gonna give me a negative out front, which will make this one positive. And the last one will give me -2x. My question to you, is this the same thing as what we started with? No, but what I can do is I can factor out a negative from the entire equation. And it looks like this guy. Again, so this one is symmetrical, but how is it symmetrical? Okay, why is it odd? Okay. 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 Okay, let's think about this. This is kind of towards the side, right? Which means that it's two separate pieces. This is actually going to be square root of x and negative square root of x. These are going to be two separate functions, technically. If I plugged in negative underneath that radical, does that produce the same thing, or does it produce the negative version of the original? Well, it doesn't produce the negative of the original. It actually doesn't produce anything. So this one is actually going to be neither. Yeah. I never said this was a good time. Okay, this one though, if we draw a line straight up and down, that is even, right? Hey, friend. Excellent. If we plug in a negative x to a 3rd power, because it's a cubic function, right? We would get the same thing. We would get the, not the same thing. We would get negative x to the 3rd, which is going to be odd.